be full credit, and we're not going to play this game that we do, or that maybe has been done in the past, when we pretend you can add, you have 150%, and then the big bad regions that we have is going to scare you. These are what you're taking. You all want to get, by and large, get into good schools. This is a measure that will differentiate you from the general population. These right in front of you are two questions that were asked on the read, on the same one. I think they were even consecutive. And these were a total of 8 points. Every one of you on this should be getting at least 6. And we'll go over what the point breakdowns are. If you're putting yourself and serious about being successful in the course, you should be getting a minimum of 6 out of these points. Make sure, by the way, that you've logged into your calculator if you haven't already, and make sure your notes are out ready to go. Because we're going to, as soon as this is done, we're going to slide right into where your notes are. Take a look at the first question. What would we go through and do in order to answer out the first part of the first question? Deanna, what would you go through and do to figure out what the average rate of change is for this? What's that? Other way around. There you go. So what would you go through, and those would be the two data points you're working with. What would you have in the numerator? What would you be subtracting out? Other way around. That's your denominator. Minus. There you go. So when you do that, yours you might have to change. Did you get 2 over 15 as your answer then?
Yes.
Take the reciprocal of that. This should come out to give you, if you did this correctly. Now this was one student's work, so this actually does need to change. This should be 306.25 minus 156.25. You get 150 over 20, 15 over 2, 7.5 feet per mile per hour. Hands up, please, if you had that right. Okay. By and large, 2 points every person should get. 2 points all of you should be getting. The only place on here that you may struggle, and we're going to be sticklers about the answers that you give. So if your answer is not tight and succinct enough, we're going to ask you to edit it to make sure that it is the second part of this question. This right here was 2 points, and this right here is 2 points. What does this rate of change mean as it relates to braking distance? So what would you go through and want to say your answers? This is saying what, frankly, pardon the language, what the hell does it mean? You can go through and find these numbers. What is the point of it? What do you want to say? Okay, hang on. Say it again. How many? There's more that we can add to that. I might even say you are very close to a 2, but that even might get a 0. Close. I think you're missing one thing, and personally, I think you get 1 out of 2 maybe on that one.
It takes an average of 7.5 feet for the car to be going around 60 miles per hour.
No.
Every mile per hour faster than we were going after 50 feet, you create 7.5 feet per
The brake distance required increases by 7.5 feet per mile on average at a speed range between 50 and 70.
That's what he get. That's good. You've got to go through and. Now, I think that the problems that we had for yours, what was yours again? Yeah, you got it. There's more on there that you needed to go through and add. What it's saying is that for each additional mile per hour of speed that you have to add on 7.5 feet of braking distance. But there's another part in there where some of you were simply at 1 out of 2 points. Frankly, some people are very, very generous with it. They give you the 1 out of 2. The second part, though, is this. What did you add in there that we had not heard yet? You know?
Speed range.
It only applies, it's only valid to draw that conclusion if you're going between 50 and 70. The rates would be different if they were in other windows. Now, some people, when we were grading this, argued, well, it said it in the question above. That doesn't make you a good lawyer. You've got to state, give it clear, succinct, and some of you think that by saying more, you're saying more. No. Sometimes you give me these convoluted answers that are 6 pages long, especially the enriched as they panic and they start writing out over and over again. And I sit there and look and go, this person, the more that's written sometimes, I go, this person knows nothing. You're trying to hit it at somewhere along the way. You very well might. But do you need to have some gigantic census in order to arrive at that answer? No, between 50 and 70 miles an hour, each additional mile an hour of speed needs that much more feet to stop or to brake. Okay? Now, that's the tough one. Most of you, I'm guessing, would be in the 3 out of 4 window on it, I hope. Everyone should be in the 4 out of 4 window for the next one. Is everyone logged into their calculator? Yes or no? Okay, so if you haven't already, it's on you. We're going to actually, let's do this right now. Log in if you haven't already. Go through right now, please, and enter just the numeric answer or answers that you got for, and it's coming out to you right now. Enter the answer or answers to this question. If you've got 2, put a comma there. Enter the answer or answers to this question. Submit when you're done. Just the numbers. 2, you put commas there. We've got 18 so far. We should have more than that. It's 22 over here, isn't it? Ish. All right, we're at 20. Looking at what I've got. Okay. So far, out of the 20 answers, I'm very happy with what I see. Now, those last 2 down at the bottom aren't what we need them to be. But the first 2 are right. Let's walk our way through. Looks like 19 of us hopefully would be getting, and you know what's funny? I'm going to tell you right now, I think, and don't get mad at me, I actually think 19 of us would get 2 or 3 out of 4. First step, we'll see why in just a second, because I can't remember what this rubric on this one looks like. Michael, what would you go through and do as your first step?
I move the x over to the other side.
Okay, so subtract the x over to the other side. And Aaron, what would your second step be after you've subtracted the x over? She's absolutely right. Just square both sides. So the reason I didn't show that first step out was because I did 2 steps at once, or whoever did this question, we did 2 steps at once. Sloppy thing, right? Now, looking at this, what would we write out next? Jake, next line going to look like?
2x minus 7 equals 25 minus 10x plus x.
Okay. What do we do now from here? Angela, what's your next step? Yeah, this is a quad equation. We need to set it equal to 0. So we're going to go through and do that. We get to this point. What would we do now from here? Jordan?
We would factor
What's it going to factor down to with 2 binomials?
x minus 4 and x minus 8.
So we've got this here. Now, the person that did this question did not show this. I would take off if this was on your papers. What do I need to see, Lily, as my next step? Absolutely correct. This is an intermediate step needs to be shown. You need to show me x minus 8 is equal to 0 and x minus 4 equals 0. So if you didn't, you're going to go through and do so now. What would you do then from there, Logan?
You set the x is equal to 0.
And what are you going to get?
X
As
equals 8 and x equals 4.
Who can tell me what the problem with stopping then is? Yeah, and here's the problem. So most of you are going to give me something that looks like this. Now, I hate this too. I don't know why your teachers don't standardize things. You give out your final answer, you put a box around it. As a reader, I know this is the answer and this is not the answer. Right now, this, in my opinion, is only getting, it's a 4-pointer, so it might be 3. It might be as little as 2.
They didn't justify some of the reasoning behind why they rejected it.
I was just talking about this with Miss Bailey, and it is striking to me, if the Regents lets this go, I'd be appalled. It says justify the answer. If you take a step in there, there needs to be justification for it. What step did we take that we did not justify yet? Yeah, and you showed one work and one doesn't. So this is the part that I'm guaranteeing almost all of you don't have on your paper. By the way, you can't write plug into the calculator to check. That's not really a thing. So you've got to go through and show me this. That's what needs to be on your paper. So if it's not, we're going to put it there now. You've got to show me, why am I keeping this answer? Why am I rejecting the other one? That's justifying your solution set. And by the way, we get into this argument too, and somebody said this before. Are they asking it as a set? So technically, if you wanted to, this is sufficient. But did you all do set builder notation before? If you didn't, that's what you list out in set builder notation, from the lowest to smallest, yada yada. But that justification needs to be there. That's the answer as a set. How many members are there of the solution set? One. Do we have that down? Yes or no? But
You don't have to like.
what do you mean? Like on some narrative? Like a sentence? No. No. And the one thing too that I really want you to understand is this. I vividly remember, because I've heard it about 750 times as well. That feeling that you all had, because there's two schools of thought when you're here. But the big thing I need you to understand is this. You all expressed disappointment that when you got to your exam last year that there was at least one, some of you indicated multiple questions that you did not know how to answer. It's my job to make sure that no matter what, we cover all of that material. If that means we go fast, so be it. If that means the material's hard, good. I'd rather you think it's hard than not know what the heck you're doing. Because at least if it's hard, you have a foot in the door. You're going, I know what I'm supposed to be doing as I get towards these answers. But yes, the material that we go through and do, it's very rigorous. It absolutely is. But the one thing that makes me happy is when I talk to the other people that do this course over at Thomas, they sit there and go, oh yeah, like that. This is one that they did, my favorite. Remember how we did this, all of those conversions from a weekly rate, you know, we gave the equations to highlight a weekly rate, a monthly rate, etc. The continuous model and how you can transform it into something where you can identify the rate. By computing, remember you took the base and raised it to the 1/12th power or something like that? The teachers at Thomas, you know what they said? We don't really think it's going to come up, so we didn't cover it. Love it. Love it. Treat them like little babies. The one thing that's so wonderful about you guys is that you all, well, I remember when you were a little kid, like, you went to Chuck E. Cheese and played the whack-a-mole game. You know what that is? The things keep popping up and then you hit it, and another one comes up and you hit it and you put it down. That's what you all are like. We've got to play whack-a-mole here. If you think you know everything, I can assure you, I'll find stuff you don't know. You shouldn't think you know everything. What you should think you know is I've got a good read on a lot of stuff. Because especially when we get to calculus, Ms. Coit and I were talking about this. Ms. Coit taught calculus for 40 plus years. And I've been doing this job for about 10 to 12. If everybody tells you they think they know everything about something, they're lying. There's no way. There's no way. In calculus, we learn new stuff all the time. So people, oh, I didn't even know that this happened. Look at this. When we do this, this happens. Same thing with algebra 2. You all have to recognize the minute you think you know something really well, you're going to find a way you don't know it yet. Period. Good way to do it. Take a look, read question number 1. You know how to do it, even if you don't think you know how to do it. Read out question number 20. By the way, on your checklist on the front, I gave it to a reason, so don't come to me and say, when is the test? I think that your test actually, even though it will be in this quarter, might be on Monday, based on our rotations. Okay? So you have one last big grade in the quarter, right? Today, is that what it spaces out to be, yes or no? Look at the front. I love you're staring at me as though I have the schedule on my forehead. Go to the front of the green packet that I gave you. I wrote it out for a reason, so you can be organized. If today we have class, right, today's Monday, when do you get to the test? Is it on Next Monday, or not? What's that? The 28th, which is,
No, I didn't take into account weekends.
wait, and you don't have class on Friday, then?
30th is next Monday.
Stop, so is that when it is?
Yeah.
We have, okay, we don't have class, just so you know, this day, so you may be taking it here, but it's gonna count. Yeah, so if that's the case, we don't have it that, just so you know, so everyone needs to be here, if you can, on Thursday, because otherwise, literally the grade book, the quarter officially ends on this day, I think, because they give us some extra leeway with the grade, but you all probably taking your exam that day, even though it's later, it'll be a chance for you to bump up your grades, because I know you sit there and obsess. By the way, did everybody get the two messages the other day? There's one from, oh, another thing, we have a quiz next time we meet, we'll go over that again. It's on the stuff we've done so far, it's 4 questions long. The other thing is to make sure that you know your quiz. Oh, I sent you out the answers to the mini test and to the actual test. Did you get those? I know I sent the test answers out through Remind and Google Classroom. Both are posted. Go through, please, and answer out the first question right now. In order to write out an exponential function, hands up please if you can tell me how many points we need to have. Please can you tell me how many coordinates you need to have in order to write out an exponential function. We got 2 people, that's we. 5, 6 of us. How many points do you need to have in order to write out an exponential function? Cece, do you know? 2. How many points do you need to have, by the way, for a line? 2. How many do you need for a parabola? 3. So we're giving out an exponential model for this. We need 2 points. Hands up, please, when you can tell me. Look at that information. Look at the narrative. Pull out 2 coordinates from this narrative. Now, he did negative 10, 150,000. And then the other one would be what? 0 and... Now, did anyone, there's an alternate way you could give points. Anybody give 2 different points?
It's 0, 150,000, and then 10.
Yes. Either one works. Yes.
Oh, my.
Okay. So what you need to go through and make sure that you take into account. Let's do it, well, who did it with these 2 points? Who did it with the other 2 points? Okay. Looks like even split, so 4 people got an answer. Wonderful. Now, what we're going to do is we'll stick with these points then. If you want to see how the other ones work, you'll go through and you can watch the first 2 sections. The first 2 classes, section 1 and 2, did it with 0, 150, and 10, 185. Now, we need to find out what our exponential regression is going to be. And Ben, how many spots after the decimal do we want people to round to? Let's do 4.
One place.
Now, go in right now. You're going to take, you should know how to take an exponential regression. So go through and do so. Take the exponential regression. Go into your calculus. Go to the table. Plug them in. Round appropriately. This stuff should be quick. And yes, I know we go quickly. Everyone's logged in. That is. So now, once we get that done, oh, hang on, whomever this is, go back, because I want us to make sure we didn't do something we need to do yet. Oh, let's, well, hit enter on that so it gets out there. I guess I'll say this. I don't like this. Go back to the X and Y and change it to what it actually is. Give it just, even if it's 2 letters, whatever these are, because they're not X's and Y's. And let's say year and population. Yeah, that's fine. POP for population. That's fine. Now, go in. Let's take our regression. We should know how to do this. Go into 4-1, and then we're going to choose option A for exponential. And there's more underneath there. Now, our X list is going to be our years, and our Y list is our population. You see how tough that is? Go down, store it, etc. Now, what is that rounded to the, how many places did I yell at you guys to make? 4. 4? All right, so Ben, tell us what it's going to be to 4 spots, please. 1.02. Okay, now, I look at this, by the way, immediately you should be able to tell. Is this exponential growth or decay? Which one? Growth. What is the yearly growth rate of this situation? Hands up, please, if you can tell me the annualized or yearly growth rate of this. We have 1, 2, 3, 4 of you. What is that growth rate going to be? 2.12%. That's fabulous. What do we need to do now? We wrote the exponential function, so that's 1. We got to use it to find the population in 25 years. So, Felix, what do I still need to do? Plug in 25 for the what? There you go. Now, make your replacement in. And Felix, what do you think about people who don't show out the replacement? Would you be friends with someone that doesn't show the substitution in? No. Who agrees with Felix? Who would be friends with somebody that didn't show the substitution in? You're everyday heroes, I agree. I'd be so outraged, I'd say, friends, we can't be friends anymore until we clean up your home. We need you to get real here. So, Jack will let us know what value you get when you get it. $566 point what?
But Mr. Mac.
Now, I want you to ask me this question, Jeff. When you go to this city, you're going to be scared. You know why? You're going to see just feet and ankles randomly walking through your direction. Or maybe one leg, but maybe only up to the middle of the path. Why? What's so strikingly strange about this city? Maybe it's near a nuclear reactor. Hearts of people. So let's say it's Rochester, and we're going to round to the nearest person.
Who doesn't like a floating?
Now, questions on that? What?
We write it out, we could write out like all of values and
If we're sitting there on something graded, is the goal to show me as much as you know or as little as you know? Okay. On your paper, you need to make the case that you've answered the question. That means you want to show more than I have down now. I want you to do so well, it's disgusting. I mean, I root for you people like nobody's business. Yes?
Would it be round to the nearest person or always round down?
I'd say to the nearest person. Yes. I think it's page 19 through 21. That's their previous question. Take a look at this second one here. I want you to read the second question here, and I want you to go through and answer. Get started on answering the second question. Angel, what are you going to do to answer this? I'd say no, because I don't have enough to pull out two. Well,
You do.
yeah, okay, fine. That's not going to help us, though, with this model. You could get an exponential regression. This isn't an exponential regression. What type of equation am I working with here? Hands up, please. Fields? It's a continuous growth model. Hands up, please, if you can tell me what I could go through and do based on the given information to figure out what the K value is. So what are you going to write out for me? 2,000 is equal to 250 times e raised to the 1.5 k power. Our job is to solve for k. I asked, and I've been asking since we started, when you do a question like this, isolate the exponential and circle what is being raised to the power. You can't multiply 250 times e. The e has a power, the 250 doesn't. What are you going to do to solve for k? Stephen?
Divide by 250.
Divide both sides by 250, and what are you going to get?
8 equals e times 1.5. I mean, to the 1.5 k power.
What needs to get done from here? Hands up, please, if you can tell me the next step. We're trying to solve for k. What would we do? 1, 2, 3, 4. What do you want to say? You can, but that's not really going to make it easier. So I think you're trying to say e to this power then raised to this. We can keep that exponent on there. We're fine with that. Yeah. We can't make equal bases happen, but that's starting to get on the right track. Well, or the log. If you're stuck, you're solving for a variable exponent. You need to know to put this in log notation. It's the easiest way for me to tell if you've been doing your homework or not. If you actually, and by the way, there's a big difference between doing it and knowing it, so let me say it that way. You've got to know how to answer those questions that are on the homework. We get to here, we can't do any more else. You don't have a common base. But what can you do? If you're stuck in exponential form, try logarithmic form. What is this going to look like, Spencer, if we put it in log form?
The natural log of 8 equals 1.5 hours.
You could also do the natural log of 8, which is log with a base of e. Now, before I even go to the answer, I love, because some people will start typing, and you're making more work for yourself. Look at what's up there. Sam, what needs to get done in order to solve for k? Perfect. Let's divide both sides by 1.5. It doesn't matter which expression you use. Now type that into the calculator. So let's go into our calculators, do control division, type in. You could do log base e or natural log. Doesn't matter. They're going to give you the same answer. Whatever you're most comfortable with, of 8, and then divide by 1.5, is that right? Press enter. Now, what is the k value? Does it say how far to round? No. Teresa, how many spots? 5. Very brave. Go above and beyond, loves. What is that rounded to 5 places going to be? Caleb, let us know when you get it.
I only have it to the 3 places on my
Go up and select it and hit enter.
1.38629.
38629, is that right? Fabulous. Wonderful. Questions on that? I'm assuming you can do this one, so we're actually going to skip this to make sure we get through more. We always run late in here. Or, yeah. But first, the next one up, it says the data below. And by the way, I know, let's deal with it now and get it out of the way. When you see a word problem, are you expecting it to be something relevant or interesting? Yes or no? I can assure you it's both. The answers to those questions. Is this relevant to you? Is it interesting to you? Probably not. Who here is fascinated with the height of some sort of awkward cherry tree? Yeah! Wonderful. Who cares? Now, when you read the questions, go through, get through your head, it's going to be, brace yourself. Your brain is going to go numb. You know, sometimes if you like lay down and you fall asleep on your arm and you feel it falling asleep, that's what happens to the frontal lobe of your brain while you're reading this question. Now, it says the data shows the average growth rate of 12 leafing something trees in Washington, D.C. At the time of the planting, the trees are 1 year old and all were 6 feet in height. What type of model best suits us? You've got 3 choices. Is it exponential, linear, or logarithmic? Looking at what's there, I need you to raise your hand when you can answer this question. Is it linear, and justify your answer? We got 1, 2, 3, 4, 5. Look at the data. Is this linear, yes or no? And this is real world data. What do you want to say, Jordan?
No.
Why?
It is not a constant rate of change.
It doesn't even approximate a constant rate of change. So it's not going to be linear. The second one, is this exponential? Yes or no, with the justification as to why. We've got 1, 2, 3 of us that can answer. Is this exponential? What's your thoughts? What do you want to say? Why?
It's exponential. It goes like up really fast, and for a while there, it's just going up by 1.
Yeah, is our growth, remember exponential growth long term is growth on top of growth. Is this growing at it, it's technically the calculus term for it is it increasing at an increasing rate? No. The other option is it logarithmic? Now, we don't know that just yet, but you should be able to do this. Go into your calculators right now, get a new table, please, and I want you to insert all of this data. And then before you rush out and do more, we're going to go through and show you how you can look at the data to confirm or dispute your findings. Take a look. We all should be pros by now by inputting this data. Now, raise your hand. No, don't do anything. Just get on this screen. Raise your hand once you've completed the input of the data. Yeah, 1, 2, 3, 4, 5, 6 of us, 7. We'll wait for everyone nice and high. Don't be shy. We're not checking for deodorant here. So if you do need some, be careful. Okay. All right. Now, what we're going to do is we're going to plot out this data. Now, I know you've got more than one way, but this is how I remember. If you go in to, is it a new page? Okay, so go to new. Insert 4. And then new page 2. Comes up now. We're going to go through and go down to where it says, is it data and statistics for 5?
Yes.
So select 5. Now, you've got all this here. It looks like garbage. Go down below. Select what your x variable is. So click on it. Now, what is it? It is the age. Is that right? Okay, so select that. Now, go to the right. Select the height. Now, look at the curve that you get. What type of graph is that? No. This is a logarithmic graph.
But it has an x-axis as the judging
What?
by the, like looking by the where it's going, it's like an x-axis as
Mm-mm. It's going to continue to increase. It's just not getting big by the same rate. It's increasing, but at a decreasing rate. These values here, it's not like, and again, to put it in the real world context of it, if you go out and you measure a tree, and it's 30 feet, you go out and you measure, right, our tree. When we come back, do we ever come back and have the tree be smaller? Does it shrink? No. Sometimes it gets so tall that it goes through the ceiling. That's why I have to cut it. Yeah, we sit there, and then the janitors, yeah, you know what they do with it every summer?
Well, I didn't think there was hope for this.
they go through, the janitors go through, they hate this tree so much because it drops the leaves, and for some reason, it's because they don't like sweeping floors. They go through and they put this, because they try to kill it every year, they put it in the girls' bathroom, and they put it in the girls' room, they put it in the boys' bathroom, and be able to find it. They put it in the girls' bathroom, where there's no light, all summer. And you know what the best part is? It's still alive. Every year. This thing has at least, they've done it every year for 13 years now. And it still comes back every time. And there's another group that started making a conjecture that every time you give a wrong answer, a leaf dies. But so far, you guys at least have given enough right answers to make sure that there's some leaves on it. But when you go through and do this, the data is going to increase. It's just not going to go at a colossally different amount. What type does this fit? Well, this is logarithmic. Now, here's what you need to understand. If here's our axes, a logarithmic graph is going to look like that. It's always increasing, but not at an increasing rate. Exponential functions increase at an increasing rate. This is increasing at a decreasing rate. Now, looking at what we have, the second part of this says, what's the average height of the trees at 1.5 years of age? You need an equation that models this data before you can determine what that height is at 1.5 years of age. So we need to come up with a logarithmic regression for this. So literally you go back to that working screen and select, find on the drop-down, logarithmic regression. So go back to 1.3, go down, 4, 1. Let's figure out what our logarithmic equation is. And yes, I know some of us love to point out that there's more than one way to do it. My way is fine. If you've got another way, congratulations, use it. I'm old. I don't do well with multiple ways to do things. Now, scroll back up, because you're going to find the equation up there, and you're going to see what the equation itself looks like. Keep going. Now, that is the format you're giving your equation in. That tells you, if you look down at that bottom gray box at the bottom, it's a plus b times the natural log of x. Is it telling you to add the a and the b values? Do you add the a and the b values? No. Order of operation, multiplication happens before addition. Now, Maddie, how many spots after the decimal do we want to list out our regression to? All? You're going to make them list out 40? Well, you're a tough cookie. But she's going to get the most accurate answer. Let's do 3. Go right now, list out what the equation itself is to 3 places after the decimal. All of you right now, list it out, please, to 3 places after the decimal. And, Deanna, can you let us know what that equation comes out to be when you get it? And then times the natural log of x. That's what your regression is. Now, the second piece of it, to answer the question, what do we still need to do, Michael?
We need to plug in 1.5 x.
Yeah, go in right now, please, and plug the 1.5 in for x. Do a 1.5 here. And yes, you need to show both. I love it. We're so apprehensive about writing. We used to have to do this by hand. That's it. Easy. So, Aaron, let us know what the value of this is to 3 places, please, once you get it. No? Did you say 15? Mm-mm. Who can tell me? Who got a different one?
1.865.
No? Oh, I did the answer wrong. Yeah, plus it. No? Shouldn't be that. Oh, because it's 1 point. What'd you get? 8 point now, 3 places. So 8 point what? Now, does that make sense? Look at the chart. 1.5 falls between 1 and 2. Does that make sense? Yes or no? There you go. Next one up. Predict the average height of them at 20 years of age. So, what would we do, Jake, in order to get an answer for that? There you go. So go through right now. Plug 20 in, and let's see what this comes out to have as its value. And hands up, please, when you can tell me what that value comes out to be. So far, we got 1, 2, 3 of us. What?
24.39 or 300. I guess if you round to 3 places.
300. That's right?
397.
397.
Oh
Okay.
wait, I'm sorry.
Now, does that answer make sense? Well, when we're looking at the question, does it make sense? Look at the data. Look at the trend. Is that a viable, is that a realistic or reasonable answer? Yes. Now, here's another question that comes up, and this is not something that gets tested on, but you do need to know what it is. There's 2 ways of saying it. What's the difference between interpolating and extrapolating the data? What's the difference between interpolation and extrapolation or extrapolation? Yeah. Yeah, we can go. You've got the right idea. Can everybody say it a little tighter?
Interpolation, the value is going to be like roughly in your data set. Extrapolation, the value is going to be outside your data set.
Yeah, it's contained within. Any value between 1 and 10 is inside of the data set. So it's inside of the data you're working. Whereas the other one, 20, what was it, 20? 20 is outside of it. Our data stops at what year? 11, okay? Now, the big thing to understand, too, is this. Extrapolation, or extrapolate, is not as accurate as an interpolation. Okay? It's more accurate to think inside than outside of your data set. Now, is this our last one? Some people think yes. All right, we've got a couple things that we're going to do before we go on. Now, actually, I like, if you want from the other sections, actually, you can see out question number. I'll actually send out a video before we're done because we've got to finish up today. Take a look, please. Let's do this. Take a look at the last question on 27. Go to page 27. Go to the second question. What are you going to do to get an answer to that question? Let's start off. Jordan, what would your first step be to solve that out?
Subtract 4 from both sides.
Subtract the 4 from both sides. So I've got 3 times the natural log of the quantity x minus 3 is equal to 1. What would we do now from here? Lily? I would say divide by 3. So now I've got the natural log of the quantity x minus 3 is equal to 1/3. What would we do to work towards an answer from here? This is where you all fall to pieces, and it's because you don't know as much as you think you do. You're very self-assured, but you're not as smart as you think. What do you want to say? Let's exponentiate this. What is this going to look like, Logan, if we exponentiate this?
X minus 3 to the 5th equals 4.
You can tell me what that would look like.
It'd be 10 to the 1/3 equals x minus 3.
Close. You're forgetting one thing on here. Hands up, please, and tell me what that is. It's an e. What's the implied base of the common log? That's a 10. The natural log goes e. Now, to solve this out, I'd add the 3. So there's 2 ways to give this answer. This right here, this is an exact answer. If it doesn't say to round, I'd say give this answer here. That's exact. Let's also give a decimal approximation. Hands up, please, if you can tell me what decimal approximation to your answer would be. Let's go 2 spots after the decimal, Michael.
4.40.
Okay. Now, go please. I'd advise next time you have class, you have a quiz. It's on the stuff we've covered so far. If you understand log notation, expanding, condensing, yada yada, you're in good shape. The other thing, though, that we need to make sure that you understand is, if you don't know your stuff, obviously it's going to be difficult for you to be successful. And if you've done the homework, you've placed yourself in a position to be successful. So, give me these points back for me, please. Give me hand these back for me, please. Give me hand, actually, give me half of that stuff. Give me hand these back, please. Give me hand these back, please. Some group assignments in here. Give me hand these back. I'm new. Missing this all weekend. And I had to get a new set. Where's your other half go? You got it, Tom. Here.
No.
Here. Hand these back.
Thank you.
If they're not here, guys, they go back in this bin on the side.
What about papers for Rebecca?
You can throw them out.
Wait, oh, that's poor Rebecca.
I know. I hope she misses us every day.
Wait, where'd you say the whole egg
You can throw it out.
Not supposed to say it.
No,
Wait, no, not supposed to say it.
This is Dorothy, right?
Yeah. Paper.
Guys, I'm going to say